Hello everyone, this is lesson 8.4, solving factored polynomials. So today we're going to learn how to find the solutions of a polynomial that's in factored form using the zero product property. So what do I mean by factoring? Well, hold on a second. All right, so factoring is the opposite of foiling. So when you foil, you take an expression like this, and you FOIL it out and you rewrite it as x squared, and then this would be plus x minus 2. When you factor, you have a simplified expression already, and you write it like this. So there's different ways that we're going to learn how to do that in next week, but for today, we're just going to have simple versions where you only need to just distribute or do the opposite of distributing. So there's a reason why we want it in factored form, and we'll learn about that in this lesson, why it's useful being in factored form versus simplified form. So once again, this is factored, and this is simplified. All right, so let's do a few warm-up questions. First of all, let's find the GCF of 12 and 28. So remember, GCF stands for greatest common factor. So the factors of 12 are 1 and 12 and 2 and 6. The factors of 28 are 1 and 28. And then I just kind of like to go down. So is it 2 and 14? It's not divisible by 3, but it is divisible by 4 and 7. So the greatest common factor then, the greatest one, this would also be 3 and 4. So the greatest common factor would be 4. How about 18 and 42? So 18 would be 1 and 18, 2 and 9, and 3 and 6. And then 42 would be 1 and 42, 2 and 21, 3 and 14. It's not divisible by 4, 5, but it is divisible by 6 and 7. So then the greatest common factor would be 6. So we're talking about greatest common factor because we're going to use the greatest common factor to factor out a binomial. Number 3, the number in hundreds of sunscreen and sun tanning products sold at a pharmacy from 1999 to 2005 can be modeled by this equation. This is a quadratic equation. It's being raised to the second power, where t is the number of years since 1999. About how many products were sold in 2002. So here is, let's take a look at our calculators. So if you open up your calculator, there are a couple ways you can do this. You can, if 2002 represents 3 years after 1999, you can plug in x equals 3 into your equation. All right, so we would do negative 0.8 times 3 squared, and then plus 0.3 times 3, and then plus 10.7. So we end up getting 4.4. So the answer would be 4.4 hundred products. And then it says use Desmos to find the year in which there were no more products sold. All right, so I'm going to open up Desmos, graphing calculator, and I'm going to type in the equation, but use y and x. So y equals negative 0.8 x squared plus 0.3x plus 10.7. Okay, so this is what a quadratic equation looks like. We're going to do a whole lesson on this. So what this means, so if I drag this around, so this top part would be the amount in 1999, excuse me, and then as As it goes down, it's decreasing, so the amount of products is declining until you reach here, which would be the y-intercept, the x-intercept, which would be, if you click on this button here, 3.85. Okay, so there's actually a way we can do this in our graphing calculators that we will learn in another lesson. But for the sake of just kind of looking at what the zeros mean, this would be your answer, 3.85. So that's when there are no more products sold. So 3.85 is the number, is the year. So that would be like 3 years after 1999. So that would be in the year 2002. Okay, now up here we said, well, it was 4,400 in 2002. Well, that was at the beginning of 2002. This is later on in the year, closer to 2003, but still in 2002, it ends up going to 0. All right, so that's what the x-intercept tells us, is when the amount is 0. So we're gonna apply that in this lesson. So let's learn about the zero product property. So this says if a times b equals 0, so if two numbers multiplied together equal 0, then one of those numbers has to be equal to 0, because in order to get 0, one of these has to be 0, because 0 times anything else is 0. So when we are finding the zeros of a function, so if we've got it in factored form, then we have something times something else equals 0. So how do we know when x equals 0? Well, either this has to be 0, either x minus 4 has to be 0, or x plus 2 has to be 0. So in order to figure out the x in which the equation is equal to 0, so this would be the y-intercept, the x-intercept, and just kind of follow along with me, it'll all click together in a minute. You would set each of the factors equal to 0 and solve for x. So if I'm solving for x here, I would add over the 4 and get x equals 4. And then here I would subtract the 2 and get x equals negative 2. So these would be the zeros of our function, or your solutions. So let's take a look at this on Desmos. So if I do y equals x minus 4, y equals x minus 4 times x plus 2, let me zoom out a little bit. This is what my equation looks like, okay? And the zeros of our function, if we set the y equal to 0, we are finding the x-intercepts, because the x-intercepts are when y equals 0. So if you click on the y-intercepts, you get negative 2 and 4. Now, we are just doing this just to look at the graph and look at what this means graphically. This is not how I want you to solve the equations. Okay, you can certainly check your answer that way, but that's not how you should solve them. All right, so for part B, you would set these two equal to 0. So negative x minus 5 equals 0, and x minus 1 equals 0. Okay, so then you would get x equals 5 and x equals 1. So for this one, it would go through the x-intercepts at 5 and 1. All right, so now for both of these, we're just going to take each factor and set them equal to 0 and solve for the variable. So 2n minus 14 equals 0 gives us 2n equals 14, n equals 7. All right, this one gives us 3n plus 9 equals 0. 3n is negative 9, n is negative 3. So these are your two solutions. For part D, 2y plus 5 equals 0 gives us 2y is negative 5. So y equals negative 5/2 or negative 2.5. And then for this 0, 7y minus 5 equals 0, 7y equals 5, y equals 5/7. All right, so let's look at an example of where we would have to factor. So we're going to work with a simple example here, and I think this should be a y here. So what you want to do, if you have two things and you want to factor something out that they have in common, first of all, they don't have any variables in common, but you would look between 12 and 42. So what's the greatest common factor between 12 and 42? And the answer would be 6, because we did a question like that above. Well, similar, I guess. So you would write 6, and then in parentheses, you would write what's left. So think about dividing 6 by 12 and 6 by 42. You are left with 2x, and then over here, you're left with 7y plus 7y. Okay, so to check your answer, if you were to distribute the 6, you should get back to the original equation. And then that would be your final answer, factored. So now something times something else. 6 is a factor, and then 2x plus 7y is a factor. All right, over here, look at the 4 and the 24. The greatest common factor here would be 4. But then what about the x's? So if you have x to the third and fourth and x to the third, the greatest common x is x to the third. So you would pull out x to the third. And then here, if you've already taken out the 4 and you've taken out 3 x's, then you're only left with 1 x. And here, you've taken out the 4 from 24, so you're left with 6. But you've already taken out all 3 of the x's, so you don't have any more x's. So we're going to leave our answer like that. Okay, part C. 14 and 21, the greatest common factor is 7. And then between y squared and y, the greatest common factor would be y. So here you're left with 2y and then plus 3. No more y's because there was only one y and we pulled it out. All right, here, between 5/2 and 1/2, the greatest common factor would be 1/2. And then between the x's, x to the 6th and x to the 4th, the greatest common amount is x to the 4th. Okay, so think 5/2, and if you pull out the 1/2, think 1/2 times what gives you 5/2, and that would be 5 over 1, or 5. So 5, and then you have 2 x's left, so x to the 2nd, and then you pulled everything out here. But you can't just leave it as nothing, you have to have a placeholder as 1. Because if you were to distribute, you want something to be there so that you get 1/2 x to the 4th. All right. So now we're going to take our knowledge of factoring, and then we're going to also solve. So for number 2, now remember, whenever you want to solve an equation by factoring, you have to have one side equal to 0. Okay, if it's not equal to 0, you have to rearrange the equation and get it equal to 0. So here, if I factor, I would factor out the 2x. That's what they would have in common. And then we're left with x plus 4. And then to solve, we would set each factor equal to 0. So set 2x equal to 0. If you divide by 2, you still get 0. So this is just x equals 0. So that's one answer. And then x plus 4 equals 0. Subtract the 4 over, and you get x equals negative 4. So that's your other solution. Okay, if you graph this in Desmos, those would be your x-intercepts. Okay, for this one, 3x plus 2 and 18x. The greatest common factor would be 3x, and then you'd be left with just 1x, and then plus 6. Okay, so if you set this equal to 0, you get x equals 0, just like the 2x. If you set this equal to 0, you get x equals negative 6. Okay, for part C, here you would pull out an a, and then you're left with a plus 5. So this a equals 0. You set a plus 5 equal to 0. So basically, maybe you're thinking, okay, you just get the opposite. Okay. And then one more here, negative 32y to the second minus 24y. Here I would pull out the negative sign. So negative, and then the greatest common factor they have is an 8, so negative 8. And then they also both have a y, so I'm going to pull out a y with it. Now when I pull out the negative sign, that means that these two negatives are going to turn into plus in the parentheses. So here we would have positive 4y, and then plus, here we would just have a 3 left. Okay, so this is going to give us y equals 0, and then this, 4y plus 3 equals 0. You would move over the 3, so that'd be 4y equals negative 3, and divide by 4, so negative 3/4. Okay, so those are your two solutions for part D. Now, for part E, part E and F, they are not set equal to 0, so we would first have to make them equal 0. So I'm going to subtract the 15n over to this side. So we would have 6n to the second minus 15n equals 0. Okay, then I would factor. So I can pull out a 3n from both of these. So then we're left with just 2n minus 5. Okay, and then for this one, I would add the 3p over. Actually, instead I'm going to add the 12p squared over to make it positive. So we would have 12p squared minus 30p equals 0. And then I can pull out, I can pull out a 6p. So then we would have 2p, and then minus 5. And then I'm going to let you solve these ones, okay, in the questions. Okay, so go ahead and give it a try. And that is the end of this lesson. We'll have another video to watch the next day that will go over word problems. All right, so that is the end of this lesson. Hope you have a great day.